Hello, y'all. What's up? We are going to look at our next day. So, wait, that looks kind of, there we go. Is that better? I don't know why it looks so dark. It's very bright in here. It could just be my computer. Anyway, we're going to do a little warm up kind of to review some vocabulary. Before we do that, though, let's make a list of, oops, got my paper on the floor. A list of the formulas that you've had so far in this unit. What are you supposed to know? Okay, so standard deviation, right? And if you make a note card or a sheet of paper, as I am, with your formulas, it makes it a lot easier. So what is the standard deviation? P, Q over N, and the square root. And remember, Q is just P minus 1, so P and Q add up to 1. Okay, that's one of the important things that we have to do so far. We also know that a confidence interval, let me put that in a different color, is P hat plus or minus Z times, if you look at the formula, it's really just the standard deviation. That's a standard deviation there times Z. And remember, we look this up on the chart that's in your notes. You don't have to memorize those. If you don't know, or it's not specified telling you which one to use, we use 95%, which is 1.96. That's kind of the standard, right? And a confidence interval, remember, tells us I'm confident, 95% confident that the true value is in between this percent and that percent. So it basically gives you a wiggle room, like, oh, I'm between 90 and 95% or whatever that is, okay? Hopefully that makes sense and you did okay on your homework. You did 1 through 5. When we're done with this video, you're gonna do 6 through 10 on that same page. So keep your notes, keep a note sheet going. And we're going to kind of warm up and review. The proportion of all students who have a dog is 0.45. Okay, so right here, is that P or is that P hat? Is it a sample? No, so it is P. Right? Suppose a simple random sample of 400 students is obtained. So that means what? And if P equals 0.45, then Q equals what? 1 minus 0.45, which is 0.55, right? So describe the sampling distribution of proportion of students who have a dog. Well, what does that mean? When you see this, describe the sampling distributions, one of the things they want you to find is a standard deviation. So the mean is 0.45, right? Because it said the proportion of all students who have a dog is 0.45, so that tells you your mean. And your standard deviation, and remember that's kind of like, well, we'll draw that in a second, is, right, P times Q all over N. So take a second, hit pause, do the math, and come back and meet me. And it is 0.0249, right? So now we're going to sketch. So by describing We want the mean, we want the standard deviation, right? Where's the center and how far are the increments up from the center, up or down from the center? So sketch it. So how do we sketch that? Do you remember that's the what? The normal curve. Hey, look at that. It's almost, okay, so there we go, right? And there's 0.45. And where did that number come from? That number came from the truth right there. Now, somebody used samples to figure that out, but they're telling us that's the truth. So then remember, we always like to go up 3 standard deviations above the mean, 3 standard deviations below the mean. And how do we do that? We add on 0.45 plus 0.0249, which gives us, what is that, 7.4749, right? And if you add 0.0249 to that, 0.4998 and 0.5247, and we go this way, we'll take 0.45 minus 0.0249. So you can pause this, and you keep subtracting. You remember that. And what's this called? The normal curve, right? And then if you subtract 0.0249 again, as you can tell, I already did the math, so I wouldn't spend too much time, but you do the math and pause me and see if you get what I got. Okay, so now this goes back to what we learned in the early fall, combining it with the language we learned yesterday and kind of putting things together. So the proportion is your mean, the standard deviation show you the increments, and you know that this much, right? 68%, 95%, 99.7. So use that rule to determine the middle 95% of all samples. Well, the middle 95, right, is going to be from here to here, because 95% are 2 standard deviations away. So we say 0.4002, comma, 0.4998. And what we can say is we must write our statement. We are 95% confident, that's coming from here. We are 95% confident that between 40.02% and 49.98% of students have a dog. Okay, hopefully that makes sense. Again, we've done this before, but we haven't been asked in this fashion. So now you're seeing the proportion gives you the mean. Describing the sampling distribution means we want to know the mean, the standard deviation. Sketching it means we're going to show a normal curve. We take the mean, we add the standard deviation 3 times because that gets us out to 99.7. This wants the middle 95, so it's these two. If it wanted the middle 68, we would be down to here. Then we could say we're 68% sure that it's this type. You can see that your percentage is going to get smaller as you move in because you have less wiggle room. You're going to be less sure, less confident if you're saying it's between 42 and 47 than if you're letting yourself go out to 40 and 49.98. And then if I said I'm 99.7% sure, I could say they're between 37 and 52. Now I've given myself a lot more wiggle room. So hopefully it makes sense that as you move out or as you go up with your confidence, you're actually scooching out with a wider amount in there because you're saying, hey, I better have a bigger pool of what's acceptable, right? Okay, how big does a sample have to be? Do I need 10 people, 1,000 people, 496 million people? How many do I need? Well, in order to do that, first we have to establish What margin of error do we want? Okay, so when you look at this, all right, right now we're trying to say how big does n have to be? Well, that's this n right here. So in order to do that, the easiest thing you can do is rearrange that formula and get n out of the square root, right? So basically, I'm going to do it for you one time. You don't have to do this because you're just going to write down what we get as the answer. But let's see how this would work. I would say margin of error equals z times, you guys know if you have a square root, you can, and I want to be clear on one thing. I don't think I've mentioned, this can be P or P hat. You can have P hat, Q hat, or PQ, whatever information you have to work with, okay? So now if I do this, right, I can multiply both sides by the square root of n, and I have n times the margin of error equals z times the square root of P hat, Q hat. Now I can divide through by the margin of error, and I've got n equals this, right? Or the square root of n, sorry, that's the square root of n we multiply by. So now I've got the square root of n equals z P hat Q hat over margin of error. Now I can't have a square root there because I want to know how big n is. So I will square both sides. And what we get is n equals, okay, z is going to be squared. The square root squared is just going to be that, right? Margin of error squared times PQ. So now we have n. Now you don't have to do this again. You can simply come over here and say n equals z squared over margin of error squared times P hat Q hat. You can write it down and use it. Okay, but there's something I need to show you about P and Q. All right, sometimes we don't know, and then there's a certain number we choose, and I want to show you why we do that so you remember. So if P hat were 0.1, what would Q hat be? It'd be 0.9. If P hat were 0.2, then Q hat would be 0.8. Remember, these two add up to 1. So I want to run down. Let's try all the P hats. We're only going to do this once. But I think it's important for me to show you why. Right? So 0.3 times 0.7, 0.6, 0.5 times 0.4, 0.3, 0.2, 0.1. So I want you to go through, hit the pause button, because if you really do this, you'll see why. And we're going to multiply them because it's P times Q. So I want you to go through here and multiply all these. Hit pause right now, multiply them, and then come back. Okay, you're back. Notice what happens when we multiply these. Okay, right here is your biggest, right? The largest percent there. So if we don't know what P is, if somebody doesn't tell us P or P hat, then this is what we use for P times Q. We use 0.25 because it's the absolute biggest one, right? Okay, so if we don't know P hat, then we replace PQ or P hat Q hat with 0.25. Okay, so if you're trying to figure out N and you don't know what P hat is, we use this. You don't have to go through and write this down every time. I just like you to see that that's the biggest. So we replace P hat with, or PQ with 0.25, okay? So now we just need to think about Z squared and the margin of error. So let's look at what that is. Let's do a problem now. Which, how big does N have to be? That's important, right? Because if you want to find out how many kids have dogs or cats or whatever it is, you have to know how many people you have to ask. Your sample has to be what? That is right. Your sample has to be random. In addition to being random, you have to get enough people, but you don't want to do too many people. So let's look. Suppose a polling organization wants to report the results at a 95% confidence interval with a margin of error plus or minus 4 percentage points. Find the number of people they would need to interview. Okay, N equals. What are we going to replace P hat Q hat with? You're right, we're going to replace it with 0.25. Because we don't know what they are, and 0.25 is the biggest we can ever, biggest out of any two. So we're going to use it, okay? So 0.25. Now, what is the number for the 95% confidence level? Remember, 95 is 1.96. Let's look back so you see where that was. You wrote it down in your notes. Here's your confidence levels. Matter of fact, I think you should put your confidence levels on your note sheet. Come on, if I can make one again, you can make one. Z, right? Maybe write these down. 99.9 is 3.29, right? 9, and these are percents. 99% is 2, and you don't have to memorize these. If this were a test, I would let you write them down, or I would give them to you probably printed on your test. But right now, I think you're in good shape if you can write them down so that you know where to find them in your notebook. You're probably a senior, and you're going to go away to college next year, and you're going to want to make a 100 in stats. There, you know me. I don't like to keep going back to a sheet of paper, so I'd rather write them down in one spot. So here's a nice formula sheet I have going on. You can pause this and add 2 years if you want to, if you haven't already done so. Okay, so now I want a 95% confidence level, so that, remember, this is kind of the gold standard. So 1.96, right? And it's Z squared over margin of error squared, another way to say that, right? Either way is correct. You can put parentheses in squared or say squared to each, and I made a big parentheses, so I'm just going to say squared. So that's Z squared, and we know that Z is 1.96. Now, a margin of error plus or minus 4 percentage points. Well, percents are out of 100, so that's going to be 0.04, because plus or minus 4 percentage points. And you all know that for percents, 4% equals 0.04. So kind of reviewing percents a little bit with that, right? So plug that into your calculator, which I need to do real quick. And I don't know, y'all, my calculator is starting to run low on batteries, and I left my charger at school. So I'm going to have to go back to the old-fashioned one pretty soon, right? So I can do 0.25 times parentheses alpha y equals 1, and I could do 1.96, 0.04, and I can square that, right? So it's 600.25. N equals 600.25. Now I'm not allowed to use that. We can't have 0.25 of a person. And in this case, I know that you're used to rounding down, but we don't want to round down. We want to say how many people. So this would be 601 people, or person, or 601 people, yeah. Okay, so in our sample, we need to go find 600 people, 601 people. We always round up for number in sample size. Okay, so if you're looking for a sample size, you need to round up. Okay, so that's the end of that lesson. So now what you're going to do is go back and do 6 through 10. You didn't do them on the first day, you just did 1 through 5. So now you're going to go to page 6 and do 6 through 10. That's the homework. Okay, so page 6, 6 through 10 now. Okay, hope you have a great day, and I will talk to you later.